It is necessary to identify which molecular gas petals are the Monster Hadron Collider before moving on to the statement. The LHC, which CERN operates, is a 17-meter-long superconductive magnet ring and, similarly, the most famous and significant particle smasher in the world. It is the height of human scientific achievement. In fact, it is so powerful that it could replicate the actual conditions of the initial interaction on Earth. However, could this device, which was meant to unlock the mystery of the universe, pave the way for something else entirely? CERN, which was established in one of the most well-known years, 1954, is among the leading organizations conducting research worldwide. With 23 member states and countless researchers, although the LHC is CERN's main project, it is only a piece in an enormous system of tests and gas pedals. Imagine a course that focuses more on subatomic particles than cars or people. In order to practice talent, diligence, and explore space itself, the LHC accelerates protons to almost the speed of light, putting them on a collision path that captures the universe's energy at the moment of the Big Bang. The impacts produce temperatures that are typically hotter than the sun's center. The protons are directed by a number of magnets on their journey, while intricate cooling systems maintain the magnets at temperatures lower than space. The LHC's pillars are designed to crash at 4 districts around the gas pedal ring, connecting with the locations of 4 molecular identifiers, CMS, ALICE, ATLAS, and LHCb. Each serves an unparalleled purpose. By looking into extraordinary molecular material science fragments, together they function as beast cameras, recording images of these collisions. Experts sort through the debris to find signs of the elusive Higgs boson, also known as the God particle, and other anomalies that reveal fragments of the universe's fundamental building blocks. This allows us to focus on the microcosm and learn more about it. But every answer raises new questions, and every revelation leads to new tests. The LHC is more than just a logical tool, it is a manifestation of human curiosity and advancement. In any case, as we push the limitations of our knowledge, we ought to consider the more existential and serious questions that arise, such as, what are the risks of examining the unknown? And what is our primary objective for witnessing and potentially unleashing forces over which we have no control? In the hallowed halls of CERN, where the limits of human understanding are constantly pushed, a shocking revelation has surfaced, one that even the researchers with the best plans hadn't fully grasped. Former CERN scientist Brian Cox, an authority in molecular physics, recently made a statement that has both fascinated and unnerved people worldwide. Cox's comments reiterate with gloomy clarity that the goal of CERN's Massive Hadron Collider is to replicate a small-scale Big Bang. Yes, you read that correctly, a miniature recreation of the event that created our universe. Physicists also succeeded in understanding the implications of this goal, highlighting the LHC's incredible capacity for new discoveries. This includes its ability to reveal the Higgs boson's privileged secrets and explore dark matter, an odd substance that constitutes a crucial component of the universe. Imagine being able to comprehend the force of creation itself, the ability to call forth the universe's actual embodiment. It is an alluring opportunity, but it is also fraught with danger. The scaled-down Big Bang is more than just a theoretical concept, it is a significant reality that exists within the LHC. The temperatures, pressures, and raw energy all replicate the states of the universe's birth. It's like being at the dawn of written history, witnessing the introduction of existence itself. Nevertheless, with such power comes responsibility, and the pressing question, what do we do in the event of an error? In fact, back in 1978, the Russian physicist Anatoly Bugorsky encountered a catastrophe that would permanently alter the course of his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction caused his head to accidentally come into the direct path of a proton beam. The beam entered through his skull and exited through his nose. Bugorsky had an incredible experience. He saw a flash of light that was 1,000 times brighter than the sun, yet he felt no pain. This episode isn't just a personal tragedy, it serves as a reminder of the terrifying power and potentially dangerous nature of particle accelerators. The beam's path left a trail of destruction, consuming tissue and bone. Yet, he remained conscious and even walked to the center for treatment. The outcome was both upsetting and captivating. The beam's path caused limited tissue damage, leading to hearing loss in one ear and partial facial paralysis. But, surprisingly, Bugorsky's intellectual faculties remained intact, and he continued his scientific career. The potential for frightening consequences is one of the hazards of a particle smasher like the LHC, and should not be underestimated. The possibility of altering the fundamental fabric of existence is a real concern, expressed by respected experts, not just science fiction writers. Among the most disturbing and fascinating issues related to the LHC's testing is the possibility of creating a tiny black hole. Researchers and the general public alike find it astounding that the LHC could create such a phenomenon, even in trace amounts. Black holes are regions of spacetime where the gravitational force is so strong that not even light can escape. They are enormous vacuum cleaners, devourers of stars and strange substances that hide in the shadows of our universe. Could such a black hole eventually grow uncontrollably, swallowing Earth from the inside? CERN researchers have assured the public that any black hole created would be unstable and would vanish very quickly. Regardless, the mere possibility has sparked discussion, fear, and awe. When protons are crushed together at near-light speed, the energy created is so immense that it can warp the very fabric of spacetime. For example, imagine a heavy object dropped onto a taut trampoline. It twists the texture. If the object is heavy enough, it creates a depression so deep that anything nearby would be pulled in. This analogy helps us understand what might happen at the LHC. In the field of quantum physics, where the world is both bizarre and astonishing, there is a theory that more dimensions may be hidden within our existence. If real, these dimensions could be tapped by the LHC to create a gravitational well, a tiny black hole. Some incredibly well-known scientists have taken an interest in this strange dance of particles. The late Stephen Hawking, for example, warned in his book that the Higgs boson could become unstable at very high energy levels. This instability could lead to catastrophic vacuum decay that would not only destroy Earth but potentially the entire universe. In his book on the future, Prospects for Humanity, renowned English cosmologist and astronomer Sir Martin Rees examined the potential risks of particle collider testing, including those at CERN. He voiced concern over the experiments conducted there. His remarks were not only wise but tinged with existential fear. He spoke of a worst-case scenario in which a botched experiment might result in vacuum instability. Although he assigned a low probability to such catastrophic outcomes. Energies produced by the LHC, while immense on a human scale, are still dwarfed by those naturally occurring in the universe. Cosmic rays, high-energy particles from outer space, strike Earth's atmosphere with forces far greater than what the LHC can replicate, and they've been doing so for billions of years without triggering any apocalyptic scenarios. Nevertheless, the sheer scale and ambition of the LHC have fueled public fascination and anxiety. From fears of micro-black holes and vacuum decay to concerns about manipulating forces we barely understand, the collider has been the centerpiece of both cutting-edge physics and existential speculation. Yet, beyond the theoretical risks lies the incredible promise. The LHC has already played a pivotal role in confirming the existence of the Higgs boson in 2012, a fundamental breakthrough that completed the standard model of particle physics and offered insight into why particles have mass. Its experiments continue to search for dark matter, supersymmetric particles, and other mysteries that remain hidden in the universe's quantum scaffolding. In essence, the Large Hadron Collider is not a doomsday device, but rather a monument to human ingenuity, a beacon of intellectual curiosity aimed at peeling back the layers of reality. It operates under some of the most rigorous safety standards ever developed, and its findings may well unlock new technologies and paradigms we have yet to imagine. Still, it is worth remembering the philosophical dimension. Every great leap in scientific progress brings with it a responsibility, to question, to reflect, and to respect the unknown. The LHC stands as a testament to our desire to explore the frontiers of existence, but also as a sobering reminder that with immense knowledge comes immense consequence. In the words of Brian Cox and many of his peers, the real danger is not the machine itself, but what it says about humanity's need to explore, even when the risks remain uncertain. It is here, at the intersection of brilliance and caution, that the future of physics, and perhaps of existence itself, unfolds. Chances of creating a stable black hole are cosmically low. Even if one were created, scientists say it would be so small and unstable that it would dissipate quickly in an energy eruption, a phenomenon predicted by Stephen Hawking and known as Hawking radiation. This would be a brief moment of massive wonder, a fleeting glimpse into the void, and then gone. Some have even gone so far as to speculate that the LHC's experiments could open a portal to another universe or dimension. Although mainstream scientists largely reject this, theoretically it has piqued the interest of many people and has become a topic of fear, and even fascination, in the question of what lies beyond our universe. Could we unintentionally unleash forces or entities that we are unable to comprehend? The notion of creating a portal to hell has even been sensationalized in the media, stoking skepticism. But how did this idea come to be, and what does it signify for scientific research? The idea of additional dimensions in string theory physics is not new. There may be more dimensions to space than the conventional three, according to a prominent candidate for a unified theory of everything. These additional dimensions may be compressed or obscured from our view, but in certain extreme cases, they may be made accessible. Visualize the LHC as a key to the cosmos that unlocks doors that have been locked since the first written records were created. When protons collide at energies never before attained on Earth, they may theoretically produce ripples or waves that probe the hidden dimensions. If these dimensions exist, the LHC may even reveal them. But before we get caught up in wild speculation, it's important to keep in mind that, despite the LHC's obvious power, there is no concrete evidence that it will open a portal to another universe, let alone to hell itself. Nevertheless, the fascination with the unknown, combined with the enigma of quantum physics, ensures that such concepts will continue to captivate the public imagination. So, should we be concerned about the LHC and its possible risks? The truth is that the scientists at CERN are well aware of the risks involved. They have taken all necessary precautions to ensure the safety of their experiments and continue to monitor and assess their work with the utmost diligence. It's easy to get carried away by dramatic headlines and fears of a worldwide catastrophe. The potential advantages of the study, the improvements in our knowledge of the universe, the discovery of new particles, and the investigation of dark matter, are simply remarkable. It's a window into the very core of the cosmos as well as a display of human brilliance. Nevertheless, like any significant scientific advance, it has risks. So we should approach it with a healthy dose of amazement, curiosity, and prudence. The frontier of scientific investigation, where theoretical physics and experimental reality converge, is symbolized by the enormous Hadron Collider. The LHC still inspires awe and fear in some people. Despite numerous safety measures and careful calculations, the machine's sheer size and the amount of energy it produces are astounding, and each new experiment opens up new scientific vistas. Although the majority of researchers are confident about the safety of LHC experiments, there are clear vulnerabilities. Nevertheless, its true potential to answer fundamental questions about the universe, such as the origins of mass and dark matter, is unlike any other in its nature. The LHC pushes the frontiers of human knowledge and our ability to regulate the natural world. As particle collisions replicate circumstances unseen since the Big Bang, what if new, unexpected abnormalities emerge that cast doubt on our comprehension of physics and the rules of the universe? The importance of these experiments prompts existential concerns on the possible results of changing the universe's fundamental composition. Nevertheless, the LHC has made significant contributions to particle physics, including the discovery of the Higgs Boson, which has improved our comprehension of the Standard Model and created a collection of future discoveries that might influence our technological future. The quest for knowledge is still one of humanity's most ambitious endeavors. Despite dangers, there are always risks associated with scientific discovery, and the LHC is no exception. For decades, tests have delved into areas of physics where intuition is no longer relevant. Physicists have attempted to comprehend nature's underlying forces, electromagnetism, gravity, both the strong nuclear force and the weak nuclear force, all essential to the evolution of matter. These four fundamental forces form the framework of the physical universe. Understanding them not only helps us explain the behavior of particles at the smallest scales but also enables us to piece together the grand puzzle of cosmic evolution, from the birth of stars to the behavior of galaxies and the structure of spacetime itself. The Large Hadron Collider represents the pinnacle of humanity's pursuit of these answers. Each new collision is not just an explosion of particles, it is a moment of discovery, a test of the boundaries of what we believe to be true. It challenges our theories, validates our equations, or forces us to revise what we thought we knew. But with such immense power comes the burden of responsibility. CERN's physicists are acutely aware of this. Every experiment is preceded by rigorous theoretical modeling, peer-reviewed safety assessments, and simulations designed to anticipate the outcome of even the most energetic collisions. This isn't science fiction, it's disciplined, cautious, methodical science. Still, public anxiety is not entirely unfounded. We fear what we do not understand, and the LHC operates on a level of complexity that even seasoned scientists struggle to fully grasp. When people hear about mini black holes or tears in the fabric of space, it's natural that fear creeps in. Add to that the media's sensationalism, and soon, a responsible experiment can be misrepresented as a reckless gamble with reality. But the truth lies in balance. Scientific progress has always walked a razor's edge between wonder and danger. The first atomic reactions were once feared in much the same way, yet they led to breakthroughs in medicine, energy, and a deeper understanding of the universe. What the LHC offers is unprecedented, the chance to unlock secrets that have remained hidden since the dawn of time. Whether it's revealing new particles, verifying supersymmetry, or shedding light on dark matter and energy, this is a machine designed not to destroy, but to illuminate. The question, then, is not whether we should fear the LHC, but whether we are prepared to embrace what it might reveal. If we are fortunate, its discoveries will lead not only to technological advancements but to a greater philosophical understanding of our place in the cosmos. If we are wise, we will treat its power with humility and respect. And if we are bold, we will keep asking the questions, knowing that the greatest risks often yield the greatest truths.